good evening and welcome back. Tonight we'll take our time with one of the quietest and strangest ideas in all of science, the matter we cannot see, but can still seem to feel in the shape of the universe. Dark matter is not something we have ever held in our hands, and not something any telescope has photographed directly, and yet astronomers have spent decades following its influence, as if listening for footsteps in an empty room. If you enjoy these slow, peaceful journeys through science and the night sky, you're always welcome to leave a like, subscribe if you'd like to return, or perhaps share in the comments where you're listening from tonight, or what gentle topic you might enjoy next. For now, let the room grow still, let your shoulders loosen, and let this be a soft little expedition into the unseen architecture of the cosmos. We will move slowly, one clue at a time, and begin with the simple and slightly unsettling fact that the universe seems to contain far more than we can easily observe. When people first hear about dark matter, they sometimes imagine a kind of cosmic fog or a shadow cloud drifting between the stars. It is a natural image, but it is not quite right. Dark matter does not behave like smoke, and it does not gather in the sky the way clouds gather above a field. It seems to be something more elusive than that, something that passes through ordinary matter, something that almost never speaks to light at all. And light is the great messenger of astronomy. Nearly everything we know about the universe has come to us through light of some kind. Starlight, radio waves, infrared glow, X-rays, ultraviolet traces, each one carrying some small note from a distant place. But dark matter is quiet in a different way. It does not shine. It does not absorb light in the ways that familiar matter does. It does not announce itself with color, and still it seems to be there. This is one of the most comforting features of science in a strange way. Science does not require certainty at the beginning. It begins with noticing a curve in a path, a mismatch in a calculation, a galaxy turning with just a little too much steadiness, a cluster of galaxies holding together more strongly than visible matter alone should allow. From these small irregularities, an idea can grow. Dark matter grew that way. It grew from the quiet sense that the universe was behaving as if there were more mass than anyone could count. If you were to look up at a clear night sky far from city lights, and let your eyes rest on a patch of darkness between the stars, you might imagine emptiness. But in astronomy, empty often turns out not to be empty at all. There are enormous spaces where almost nothing can be seen, and yet those spaces may still shape everything around them. Gravity is patient like that. Gravity does not need a bright surface. It does not care whether something glitters. It only cares that mass is there. And for a long time, mass seemed to be missing. One of the earliest hints came from the motion of galaxies. In the familiar way we imagine a galaxy, there is a bright core, a long soft spiral, and a faint halo of stars trailing outward. Yet when astronomers measured how the outer stars moved, they found something odd. The stars at the edge were orbiting too quickly. If the visible matter were all there was, the galaxy should have been flung apart more easily. Instead, it held together. It was as if a great invisible hand were adding weight. There is something almost bedtime-like about a mystery that begins with a moving pattern. The sky at night appears calm, but deep below that calm are motions, balances, and delicate forces. The moon keeps its orbit. The planets keep their paths. The stars move in their own vast circles. And somewhere among those motions, dark matter leaves its faint signature, not as an object we can plainly see, but as a relationship between things we can measure. That is how it often works with the cosmos. We know a mountain by the shadow it casts on a slope. We know an unseen planet by the tug it places on a neighbor. We know an invisible substance by what it allows and by what it refuses to allow. Dark matter refuses to reflect light, at least in any obvious way. It refuses to form the bright structures we know from atoms and chemistry. It seems not to clump into stars or planets or familiar solid things. If it exists, it is not the ordinary stuff of chairs, stones, oceans, or people. It is not the matter you and I live among every day. And yet it appears to be woven through the universe in a very old way, perhaps from the early days after the beginning, when the universe was still hot, dense, and young. In that early era, tiny differences mattered enormously. A slight difference in density could grow into a future galaxy. A slight gravitational pull could become a gathering place for gas and dust, and then for stars. It is possible that dark matter was there, patiently helping to create the scaffolding on which all visible things later formed. This makes it feel less like a strange addition to the universe and more like a hidden support beam. Not decorative, not visible in the bright center of the room, but necessary to the whole structure. And still, the support beam is not directly in sight. Scientists have tried to understand what dark matter may be by observing its effects in many places. They have looked at galaxies spinning faster than expected. They have studied clusters of galaxies. They have watched light bend around massive objects in a phenomenon called gravitational lensing, where distant galaxies appear stretched, warped, or doubled by the gravity between us and them. Those distortions can reveal where mass must be sitting, even if no light comes from it. That is a beautiful kind of astronomy, really. A kind that listens with the eyes, but also with patience. You do not always need to see the thing itself. Sometimes you see the curve it makes in the world. In the quiet of a night room, it is easy to appreciate that thought. Many things in life are understood only by their influence. A conversation that changed your mood, a season that softened your habits, a passing person who left a room warmer than they found it. The cause may be hidden, but the effect is real. Dark matter is like that at a cosmic scale. It seems to reach into the shape of galaxies, the motions of clusters, and even the large framework of the universe itself. And because it remains unseen, there is a certain stillness around it. It does not become less real because it is hard to capture. It remains a question worth following, a question with a very large shadow. To understand why dark matter became such a serious idea, it helps to imagine a galaxy as a kind of slow-moving wheel. Not a perfect wheel, of course. A galaxy is far more graceful and irregular than that. But there is a pattern to how its parts turn. The center pulls, the outer stars circle, gas and dust follow curved paths. The whole system is held together by gravity like a soft, immense promise. Then astronomers began to measure the promise and compare it with what they could see. The math did not settle neatly. The outer regions of many galaxies were turning as if there were extra mass spread through a much larger area than the bright stars suggested. If the visible matter alone were responsible, the stars farther out should move more slowly, much the way planets farther from the Sun move more slowly in our solar system. But galaxies often do not follow the simple expectation. Their rotation curves, as scientists call them, stay unexpectedly flat. That phrase sounds technical, but the image is simple enough. It is the difference between a predicted fade and an observed steadiness. The stars should have slowed more than they did. They did not. So something else had to be contributing to the gravity. And so one begins to imagine a halo, not a halo of light, but a halo of mass. A large unseen sphere surrounding the visible galaxy, extending much farther outward than the starlight. The idea is one of those graceful scientific ideas that seems at first like a patch, and later becomes the best available map. A map of something invisible. What is especially calm and curious about this mystery is that the evidence did not arrive all at once. It appeared in many forms, from many different astronomical observations, in different decades and contexts. Scientists did not wake up one morning and decide dark matter must exist. They were pushed there by repetition, by stubborn data, by a pattern that kept returning in different places. One of the early figures connected to the story was Fritz Zwicky, who studied the Coma cluster of galaxies in the 1930s. He noticed that the galaxies in the cluster seemed to move too quickly to be held together by the visible matter alone. He suggested there must be some missing mass. At the time, the idea did not become a universal conviction, but the clue remained. Years later, Vera Rubin and others studied the rotation of galaxies in greater detail. Her work gave the mystery a strong and durable shape. Again and again, galaxies seemed to rotate in ways that suggested more mass than the eye could count. The result was not a sudden revelation, but a slow accumulation of confidence that something important was being overlooked. And perhaps that is part of why the topic is so restful, in a paradoxical way. It is not about a single thunderclap of discovery. It is about listening carefully and noticing that the universe has been speaking softly for a long time. The idea of hidden mass also appears in the behavior of galaxy clusters, those great gatherings of galaxies bound together by gravity. There, too, visible matter appears to account for only part of the structure. The movements of galaxies, the temperature of hot gas between them, and the overall binding of the cluster all suggest a larger gravitational presence. It is as though the cluster is sitting inside an enormous, unseen basin of mass. When light from distant galaxies passes through such a region, the path of the light can bend. The amount of bending tells astronomers about the mass responsible. This bending does not care whether the mass glows. It responds to gravity alone. So if light takes an unusual path, the hidden mass leaves a kind of fingerprint in space. There is something deeply elegant about that, a fingerprint without a hand in sight. In a bedtime mood, one might imagine a dim room with a single lamp and shadows along the walls. You cannot always see where the furniture ends and the dark begins, but you can feel the shapes by moving carefully through the room. Astronomy often moves that way. It is not all bright maps. Sometimes it is inference, patience, and the quiet trust that patterns mean something. The visible universe is not false, far from it. Stars are real, gas clouds are real, dust lanes, planets, moons, galaxies, all very real. But they may be only a portion of the whole. Dark matter suggests that the universe has layers and that one of the largest layers has remained stubbornly out of view. The phrase dark matter itself can sound almost too neat. It feels like a label for an unresolved drawer, but it has endured because it points to a genuine problem. Something adds gravity, something shapes the large-scale universe, something is there and the cosmos keeps acting as if it is there. And because the universe has such a long memory, it may have been there from the start. That is what makes the topic feel large and peaceful at the same time. Large because it concerns the architecture of everything. Peaceful because the mystery does not rush, it waits. It has already waited billions of years. It can wait a little longer while we listen. There are moments in science when a question is not solved so much as held gently. Dark matter is one of those questions. A great many ideas have been proposed over the years. Perhaps it is made of particles unlike the ones we know. Perhaps it is made of very cold, massive particles that barely interact except by gravity. Perhaps it is something else entirely, some extension to physics we have not yet understood. But before any answer can be accepted, it has to fit the clues. And the clues quietly keep accumulating. One of the hardest things to picture about dark matter is not just that it is unseen, but that it appears to be almost unresponsive to light. Ordinary matter, the matter that makes stars, planets, dust, water, and people, is built from atoms. Atoms interact with light in many familiar ways. They absorb it, emit it, reflect it, scatter it. This is why the world is visible at all. Dark matter does not seem to join that conversation. If it did, even faintly, we might find it by now in a more direct way. But the present evidence suggests it either interacts extremely weakly with light or not at all. That makes it harder to detect in the laboratory and harder to model in the imagination. We are used to substances having some ordinary texture in experience. A stone can be touched, water can be poured, smoke can be seen drifting. Even air, though invisible, can be felt moving across the skin. Dark matter has none of these comforts. It is a substance inferred from gravity and gravity alone. This does not mean it is magical. It simply means the universe is larger and stranger than the everyday scale that shaped human senses. Our eyes evolved for daylight, for survival, for nearby things. They were not made to directly survey the invisible scaffolding of the cosmos. So the difficulty is not really a failure. It is a mismatch between the scale of nature and the scale of perception. That mismatch appears often in astronomy. The Milky Way itself is so large that our minds can barely keep its shape in focus. Distances between stars are so vast that empty space dominates. And beyond our own galaxy, the universe becomes a layered field of systems, each one orbiting, grouping, stretching, receding. Dark matter may be part of what gives all of that structure its continuity. Some theories propose that dark matter is made of weakly interacting massive particles, often called WIMPs. The phrase sounds almost playful, but the idea is serious. These hypothetical particles would be heavy enough to contribute significant gravity, yet so reluctant to interact with ordinary matter that they would pass through us and through the Earth with almost no notice. That idea has a certain haunting calm to it. You could imagine an invisible rain falling constantly through the room, through the floor, through the walls, through your hands, and never once making a sound. Not rain exactly, but a stream of particles threading the universe. Of course, that is only one possibility. Other suggestions include axions, very light particles that would behave differently, or other hidden sector theories, in which dark matter belongs to a family of particles and forces not yet recognized in our standard picture of physics. Each proposal tries to account for the same broad clue, the missing mass, and because the clue is so large, the answers have to be as careful as possible. There is also an important distinction between dark matter and dark energy, a distinction that can be easy to blur when first hearing about them late at night. Dark matter seems to add gravity, helping structures form and stay bound. Dark energy, by contrast, appears to drive the accelerated expansion of the universe. One helps gather, the other seems to spread. They are different mysteries, even though they live in the same cosmic conversation. That conversation is ongoing. Sometimes scientists search for dark matter directly in underground detectors, buried deep beneath mountains or set far below the surface, where cosmic rays and ordinary noise are reduced. In those quiet chambers, researchers hope a dark matter particle might very rarely collide with an atom and leave a faint signal. It would be a tiny event, easy to miss, requiring patient instruments and careful analysis. That image feels appropriate for the topic. A hidden interaction taking place underground, in almost complete stillness, while above it the world goes on with traffic, weather, and birds. The universe is like that sometimes, allowing important events to happen far from the center of attention. Other searches occur in particle accelerators, where matter is given extraordinary energy to see whether new particles can appear. Still other efforts look to the sky itself, watching for signs that dark matter might annihilate, decay, or leave indirect traces in cosmic rays or gamma rays. The methods vary, but the spirit is the same. Follow the clue, keep listening, and if no direct signal arrives yet, the absence itself becomes part of the information. Science is often patient with absence. The non-appearance of a thing can narrow the field. It can show which stories are less likely and which ones remain standing in the quiet. So dark matter continues to inhabit that middle space between confidence and uncertainty. It is not a rumor and not a mere speculation. It is a serious answer to a serious imbalance, and at the same time it is still a question in motion. The cosmos has left us with a note, and we are still learning how to read it. There is comfort in that ongoingness. Not every mystery is meant to close quickly. Some are meant to shape the way we think for a long time. Dark matter has done that. It has changed the way astronomers imagine galaxies, clusters, and the distribution of mass across the universe. It has also changed the emotional shape of astronomy itself, reminding us that what is invisible may still be central. We can live with that thought for a while slowly. What seems absent may be supporting the whole pattern. And the pattern in the night sky remains beautifully large. If you step back far enough from individual galaxies, the universe begins to look like a vast web. Not a spider web exactly, though the resemblance is sometimes mentioned, because both have delicate threads and open spaces. On the largest scales, galaxies appear arranged along filaments and nodes, with enormous voids between them. It is a structure that feels both ordered and airy, as if the cosmos were gently woven. Dark matter is thought to play a central role in that web. Long before galaxies fully formed, tiny variations in the density of matter and radiation spread through the young universe. Over time, gravity amplified those variations. If dark matter was present, it could have begun gathering first, creating concentrations that later pulled in gas. The gas cooled, stars ignited, and galaxies took shape around the unseen scaffolding. In this view, dark matter becomes not a late addition, but a kind of foundation. Like the silent framework inside a shell, or the hidden beams inside a hall, it gives shape before anything decorative appears. The visible universe, then, may be only the bright edge of a much larger architecture. This idea can be especially soothing to think about late at night, because it reminds us that the universe is not random in the crude sense. It has structures, dependencies, and rhythms. Things are connected, even if the connections are not immediately visible. A galaxy is not simply a glowing island. It sits in a context, in a larger arrangement, in a deep framework of mass and gravity. There are moments when astronomers map dark matter using gravitational lensing and find that the invisible mass does not distribute itself in exactly the same way as the stars. The mismatch can reveal collisions between galaxy clusters, where the hot gas lags behind while the dark matter passes through more readily. These collisions have given some of the strongest visual evidence that dark matter is real and distinct from ordinary matter. One famous example is the bullet cluster, often discussed because it presents a dramatic separation between visible gas and gravitational mass. Even without seeing dark matter directly, scientists can infer its presence from where gravity seems to be concentrated. In those observations, the universe seems almost to underline its own notes. Look here, it says, not with words but with force, and yet even dramatic evidence remains quiet in an everyday sense. No sirens, no sudden flash in the sky, just careful measurement, image after image, model after model, a patient accumulation of agreement. Dark matter also appears to matter, literally, for the way galaxies keep their shapes. Spiral galaxies with broad disks, dwarf galaxies with relatively little visible matter, and massive clusters of galaxies all seem to point toward additional gravitational structure. The details vary, but the hidden mass keeps reappearing like a familiar motif in a long piece of music. That repetition is one of the reasons scientists take it seriously. One clue alone can mislead. A dozen clues that point in the same direction begin to form a reliable path. Still, the question of what dark matter actually is remains open. It may not be a single thing. There may be several kinds of particles. There may be interactions too subtle for current instruments. There may even be features in gravity itself that we do not yet understand well enough, though most evidence today strongly favors some kind of unseen matter. The uncertainty is not a weakness in the process. It is the process. When a room is dark, it takes time for the eye to adjust. When a subject is vast, it takes time for theory and observation to meet. The universe gives its answers gradually. And perhaps this is why dark matter continues to inspire both scientists and ordinary listeners. It sits at the edge of knowledge without becoming harsh or theatrical. It is mysterious, yes, but not melodramatic. It is the kind of mystery that invites attention rather than alarm. You can imagine standing at the edge of a field before dawn. The sky is still blue-black, the world is still quiet, and the shapes of trees and hills are only partly visible. You know there is more there than your eyes can clearly separate. You wait. Gradually, the land becomes distinct. In cosmology, however, the waiting can last much longer. The web of galaxies, the motions of clusters, the bending of light, the growth of structure, all of these are part of one slow picture. Dark matter seems to be one of the threads holding that picture together. It may not be the only thread, but it is certainly among the most important ones. And the more carefully we look, the more the universe seems to be built on a mixture of seen and unseen. That is not a discouraging thought. It is simply a larger one. The visible stars remain bright. The invisible mass remains influential. Both together make a universe that is more layered than it first appears, and the layering in its own quiet way is beautiful. The search for dark matter is one of the most patient efforts in modern science. It is patient not only because the answer is difficult, but because the methods themselves demand stillness. Deep underground laboratories, shielded from background radiation, operate in a kind of scientific hush. Detectors are built with extraordinary sensitivity, hoping to catch a signal so faint that it may appear only once in a long while. That sounds almost like listening for a distant bell inside a mountain. Researchers also use liquid xenon, germanium crystals, and other carefully chosen materials to detect possible interactions. The apparatus is designed to notice a tiny flash of light or a slight vibration, a tiny evidence trail left by something that should almost never touch ordinary matter. These experiments are complicated, expensive, and often quiet in result, which is to say they are very much like the work of astronomy itself. Watch carefully. Wait, measure again. There is no shame in a long search. The cosmos is not in a hurry, and neither are its clues. Sometimes no direct detection appears, and that too matters. It helps rule out certain particle masses, certain interaction strengths, certain versions of the idea. In that sense, every patient experiment trims the path a little more. A narrow path may not feel dramatic, but it is easier to walk than a wide, uncertain plain. If dark matter is a new kind of particle, it may be more elusive than many hoped, or it may simply require better instruments, different energies, more refined methods, or a longer baseline of observation. Either way, the effort continues. Meanwhile, astronomers keep looking upward. Surveys of the sky, maps of galaxies, and careful measurements of cosmic microwave background radiation all help constrain the nature of dark matter. The early universe leaves patterns in that ancient afterglow, patterns that tell us how much matter there was, how quickly structures grew, and how the balance of forces behaved in the beginning. That ancient afterglow is itself a kind of bedtime image, a soft remnant of a younger cosmos, stretching across the sky like a faint memory. It reminds us that the universe keeps records in subtle ways. Even when no object is directly in sight, the background can preserve a history. Dark matter may have left its signature there too. Scientists often describe the universe as a laboratory, but at times it feels more like a patient archive. Light from distant epochs arrives now, carrying information from long ago. We read it slowly. We cross-check it, we compare it with our theories. It is a humble way to know things, and a remarkably successful one. The search for dark matter also has a philosophical side, though not in a grand or abstract sense. It asks us to accept that the most important parts of a system may not be the most visible. This is true in ecosystems, in families, in cities, and in galaxies. The obvious part is not always the essential part. A tree is not only its leaves, a city is not only its lights, a galaxy is not only its stars. There is something restful about recognizing this. It reduces the pressure on what is immediately seen. It teaches a kind of humility. The visible world is rich, but it may not be complete, and yet the hidden part is not distant in a cold sense. It is already affecting what we experience. The shape of the galaxy, the behavior of clusters, the timing of structure formation, all of that has been influenced by whatever dark matter may be. We live inside the result. That is a striking thought if you linger on it. We are not looking at dark matter from outside a finished universe. We are part of the universe that dark matter helped shape. The stars in our sky, the heavy elements in our bodies, the long history of matter becoming more complex, all of that belongs to a larger story whose foundation includes things we cannot yet name with confidence. And perhaps naming will come slowly, if it comes at all. Some scientific questions are solved by a single decisive experiment. Others are solved by an atmosphere of evidence that thickens over years. Dark matter may be one of the latter. 1,000 small measurements, a dozen large surveys, a handful of innovative detectors, and the slow sharpening of theory. Piece by piece, there is no need to hurry this kind of knowledge. In a bedtime frame of mind, the patience itself becomes comforting. The universe can wait while we rest. The question will still be there in the morning, and the morning will still be part of the same grand fabric. Dark matter remains quiet, but it has never been absent from the conversation. It is one of the reasons the cosmos feels both intimate and vast. Intimate because gravity touches everything near and far. Vast because the greatest parts of the structure are not entirely visible. In that combination, there is a gentle kind of awe, and awe, when held softly, can be a very good companion to sleep. The question of what dark matter is made of has inspired a great deal of careful thought and a great many elegant possibilities. Scientists do not propose one answer because the universe is being playful. They propose many because the evidence has not yet chosen one for us. There are the WIMPs, the weakly interacting massive particles, a class of hypothetical particles that would be heavy enough to influence gravity and subtle enough to avoid easy detection. There are axions, which were originally suggested for other reasons in particle physics, but later became interesting as dark matter candidates. There are sterile neutrinos, a more elusive version of familiar neutrinos, and a number of other ideas involving hidden sectors or particles that only weakly communicate with ordinary matter. Each possibility has its own texture, its own kind of mathematics, its own set of expectations. What is lovely about these ideas is that none of them requires the universe to be simple in a shallow sense. Simplicity and complexity are not opposites. Sometimes the simpler answer is simply that the world contains a kind of order we had not anticipated. Sometimes the complex answer turns out to be necessary because nature has more than one layer of behavior. Dark matter may be one of those layers. If it is made of particles, those particles might be relics from the early universe, tiny survivors from an era when temperatures were so high that familiar distinctions had not yet settled into place. In that hot beginning, the cosmos was dense with possibility. As it expanded and cooled, some particles vanished, others remained, and the balance of what survived may have included the matter we now call dark. That is a kind of cosmic archaeology, really. Looking at what survives tells us about what came before. The search for particles also touches on the possibility of self-interacting dark matter, in which dark matter particles may interact with one another more strongly than with normal matter. That could help explain certain features in galaxy shapes or cluster behavior. It is another reminder that the story may not be a single simple one. The dark sector, if it exists, could have its own private weather, so to speak, its own internal rules. A private weather system in the universe, moving without light. Some scientists have even entertained the possibility that the nature of gravity itself might need adjustment on very large scales. Modified gravity theories try to explain the observations without invoking a new matter species. These ideas are important to consider because science benefits from alternatives, yet many observations continue to align more naturally with the presence of unseen matter than with a change to gravity alone. So the search goes on, steady and unhurried. It is easy, in the glow of a screen or the softness of a lamp, to forget how much of astronomy is built from careful comparison. Theory predicts. Observation responds, theory changes, observation narrows. The exchange repeats slowly and beautifully like waves at a shore. Dark matter remains in the middle of that exchange. Its possible particles are not just names in a list. They are attempts to describe a real unknown with honesty. Scientists do not invent these candidates lightly. They build them to match evidence, to survive tests, to remain plausible under the pressures of measurement. This is why unresolved science can still be deeply satisfying. It is not confusion for its own sake. It is disciplined curiosity. In a way, dark matter asks the same question again and again in different accents. What makes galaxies hold together? What allows structure to grow as it did? What unseen mass bends the light? What hidden ingredient is already woven into our best measurements? The answers may be waiting in a particle, or in several particles, or in something that still lacks a proper name. But even without the final answer, the map of possibilities is useful. It guides experiments. It sharpens telescopes. It changes what we expect to find in the dark. And perhaps that is enough for tonight, to let the question stay open and friendly. Not every open question needs closing at once. Some questions are best appreciated slowly, like a long avenue at dusk or a dark shoreline where the tide moves in quietly. The universe has many such avenues. Dark matter may be one of the broadest, and broad paths, when walked slowly, can feel almost like rest. To understand dark matter fully, scientists often look backward, not just outward. The early universe is one of the best places to test a theory because conditions there were extreme, and the traces left behind are still measurable. The cosmic microwave background, large-scale galaxy clustering, and the abundance of light elements all carry information about the young cosmos. And that young cosmos seems to have needed dark matter. Or at least, the data fit very well with a universe that contained a substantial amount of non-luminous matter. In the early stages, ordinary matter was tightly coupled to radiation. Photons and particles interacted constantly, making it difficult for ordinary matter alone to collapse into large structures quickly. Dark matter, if it was present and more inert, could begin gathering earlier and more quietly, giving gravity a head start. That head start matters. It means galaxies could form in time. It means clusters could grow. It means the universe, instead of remaining a more even fog, could develop texture and shape. Dark matter may have served as the patient outline around which the luminous universe painted itself. This makes the early universe feel less like a place of chaos and more like a place of emergence. The ingredients were there, the rules were there. Over time, structure slowly unfolded. Imagine a room with curtains drawn before dawn. There is no detail yet, only shape. Then the first light arrives and edges begin to separate. The table, the chair, the window, the corners of the room. The universe may have opened in a similar way, with dark matter providing one of the first hints of form. The cosmic microwave background is especially important because it gives us a snapshot of the universe when it was very young, about 380,000 years after the beginning. Tiny temperature fluctuations in that ancient radiation correspond to the seeds of later structure. When models include dark matter, those fluctuations match observations far more closely than when they do not. That is not a flashy kind of evidence. It is more like a soft agreement between different kinds of measurements. But in science, soft agreement repeated many times can become very powerful indeed. The universe, even in its earliest visible memory, seems to bear the mark of invisible mass, and that is a remarkable thought to carry. The things we cannot see now may have been shaping the cosmos since before stars existed, before galaxies, before planets, before anything with a familiar face. The past of the universe is not gone. It is still present in the background radiation, in the arrangement of galaxies, in the motion of clusters, in the bending of light. It survives as evidence. Science often works that way, using the present as a window into the ancient. There is something almost tender about that. The universe has left us with traces, and those traces are enough to begin understanding a story older than any on Earth. Dark matter belongs to that story. Whether it is a particle species, a whole hidden sector, or something stranger still, it seems to have been there at a crucial formative time. Its influence may have been not dramatic but foundational. Not a firework but a frame, and frames matter. A painting can be beautiful without one, but a frame gives shape, gives edge, gives a boundary in which the image can be seen clearly. Dark matter might be one of the frames of the visible universe. The stars are luminous. The gas is luminous. The background radiation is luminous. But the shape that holds them together may depend on something that remains dark. The cosmos, then, is partly a visible image and partly an invisible support. That balance feels worth lingering over. It is a calm correction to the instinct that only the bright things count. In astronomy, the bright things are precious, but the dark things may be just as important, perhaps more. As the night deepens, the idea becomes less abstract. It starts to feel like a principle of attention. Look carefully. Trust patterns, consider what is missing. The missing piece may not be absent at all, it may simply be difficult to illuminate. And the universe, by its nature, has no obligation to be easy, but it is generous with clues, and one of those clues may be sitting right inside the shape of the early cosmos, quietly asking us to notice. Because dark matter is such a popular phrase now, it can sometimes attract misunderstandings. One of the most common is the idea that dark matter must simply be ordinary matter hidden in a dark place, like black dust, cold planets, or dim stars. But ordinary matter, even when difficult to see, still interacts with light in predictable ways. It can glow when warmed, absorb radiation, block starlight, or emit infrared signals. Dark matter does not seem to do those things in the usual way. It is also not the same as dark energy. That distinction can feel small at first, but it matters a great deal. Dark energy is associated with the accelerating expansion of space, while dark matter is associated with gravity that helps hold things together. One is a mystery of spread, the other a mystery of gathering. Another misconception is that scientists have no evidence at all. In fact, the evidence is substantial, even if the true nature of the substance remains unknown. We may not know the exact identity of dark matter, but we know a great deal about its effects. This is often how frontier science works. First, you understand the consequences, then slowly, perhaps much later, the cause becomes clearer. A final misconception is that unknown means imaginary. In science, unknown simply means not yet identified. That is an important thought to keep close. The universe is full of realities that were unknown for a very long time. Neutrinos were proposed before they were detected. Black holes were long theoretical before being strongly confirmed. Many things that now seem obvious were once deeply uncertain. Dark matter may one day join that list in a more fully understood form. For now, it remains an explanation with broad support and unfinished details. That can be frustrating if one wants a neat answer, but it can also be intellectually beautiful. It means the map is still being drawn, and we are alive during the drawing. The universe is not merely full of things we have not discovered. It is also full of relationships we have only begun to understand. Dark matter may be one of the quietest of those relationships, shaping the grand design without asking for attention. And perhaps that is enough for tonight. The stars can remain where they are. The galaxies can keep turning. The unseen scaffolding can stay in place while the room grows softer, while the mind lets go of the need to solve every question at once. If sleep is near, let it come gently. If you are still awake, let the thought remain simple and calm. Somewhere out there, the universe is carrying more than it shows. Some of its weight is visible, some of it is not, and both together make the night sky what it is. A quiet, vast, unfinished thing, and with that we can rest beside the mystery for a while and let the dark hold its own. Yet even when we rest beside a mystery, it can be comforting to linger a little longer in its shadow, to let the mind wander softly through the older questions that dark matter has awakened. For there is something ancient in this kind of wandering. Human beings have always lived among things they could not see directly. Long before telescopes, long before equations written on clean pages, there were the same silent intervals between visible events, the same need to infer the hidden from the seen. A farmer in a valley could not see the mountain spring that fed the stream, but the water told the story. A sailor at night could not see the whole ocean beneath the keel, but the movement of the vessel suggested depth. In the same way, astronomers read the sky by what it does, not only by what it appears to be. This is one of the quiet pleasures of science. It resembles an old craft, not in the sense of superstition, but in the sense of patient observation. Someone watches the way a shadow falls across a wall. Someone counts repeated motions. Someone notices that a pattern fails to close. That small disturbance, that barely noticeable irregularity, becomes a doorway. An invisible thing has touched the visible world. Dark matter has entered our understanding in exactly this way. It is not a creature glimpsed directly in the darkness as a mythic beast might be. It is more modest than that, and in some ways more intriguing. It is a presence inferred from balance, from motion, from the fact that galaxies do not behave as expected if only ordinary matter is present. The stars at the edges of a galaxy move as though held by extra weight. Clusters of galaxies bend light as though they contain more mass than can be counted by brightness alone. The sky leaves a faint signature of hidden architecture. It is rather like walking through an ancient ruined city at dusk and sensing, from the outlines of foundations, how large the vanished buildings must once have been. The stones remaining on the ground do not tell the entire story, but they tell enough to suggest grandeur. A column base implies a column, a road implies traffic, a cistern implies thirst. In astronomy, the same kind of reasoning can feel almost archaeological. We read the remains, we imagine the whole, and there is a subtle beauty in that. An unfinished map can be more intriguing than a completed one because it still invites thought. It still allows the imagination to move carefully across open ground. Dark matter occupies that kind of space in the mind. It is not a decorative mystery. It is structural. It appears at the level where the universe itself is organized. To think about it is to think about the possibility that reality has layers, and that some of the most important layers are not the ones that shine. There is also something quietly humbling about how modern this mystery is. Ancient people looked at the heavens and saw gods, omens, pathways, cycles of return. They recorded eclipses with awe. They tracked planets in patient loops. They built observatories in stone and aligned temples to the sky. Some of their questions were different from ours, but the feeling was similar. The visible world was not enough. Something behind it seemed to govern the pattern. The Babylonians, with their meticulous records, understood the importance of repeated observation. The Maya followed celestial cycles with remarkable care. In many places across many centuries, human beings looked up and sensed order. They did not have the language of dark matter, of course, but they had the intuition that appearances do not exhaust reality. Even in myth, this intuition returns again and again. There are hidden realms under the earth, secret waters below the mountains, invisible threads binding destiny, gods who move behind the curtains of the world. Such stories are not science, but they are a testament to a deep human recognition. The world is larger than the part that greets the eye. What is unseen may still be active. What is silent may still be shaping events. Dark matter has no need for myth to make it real, but mythology helps us understand why this sort of reality feels familiar. The idea of an unseen presence is older than any instrument we use to detect it. And still, science asks the harder question. Not merely whether something hidden exists, but what it is made of. That question has led researchers through many possibilities, some of them elegant, some of them strange, some of them now set aside like old maps with wrong coastlines. One possibility is that dark matter consists of as yet undetected particles, perhaps very light, perhaps very heavy, perhaps interacting only weakly with the familiar world. The phrase weakly interacting sounds mild, almost modest, but it is one of the reasons this mystery has lasted so long. If the particles do not readily absorb or emit light, and if they barely collide with ordinary matter, they may pass through planets, stars, and human bodies almost as if they were mist. There is something almost oceanic about that idea, a sea we cannot feel, a current that passes through us without leaving a trace. Yet the same invisibility that makes the problem difficult also makes the search delicate and beautiful. Scientists build detectors deep underground to shield them from cosmic noise, as though listening in a quiet cavern for a whisper. They place instruments in mines, in mountains, in laboratories filled with careful silence. They wait for the rare interaction, the faint recall, the tiny sign that something unseen has brushed past the known world. This is not a story of dramatic flashes. It is a story of patience, of counting, of reducing noise, of treating absence itself as data. There is a peculiar serenity in that sort of work. The universe does not hurry, and neither do the questions that matter most. Some proposed candidates for dark matter have acquired names that sound almost like folklore. Axions, WIMPs or weakly interacting massive particles, sterile neutrinos. Each idea carries its own history, its own brief period of prominence, its own hopes and disappointments. The names can sound technical, but beneath them lies a simple human effort to answer a haunting question. What fills the missing mass? It is worth pausing on the word missing, because it can mislead. Dark matter is not necessarily missing in the sense of being lost behind a door. It is missing in the sense that our ordinary inventory does not account for it. The cupboard does not seem to contain enough to explain the weight of the house. The ledgers do not balance unless one acknowledges a hidden entry. Sometimes the universe behaves like that. The account books of nature contain lines we did not expect. And because the issue involves mass, gravity, and structure, the implications are large and ancient in scale. Dark matter seems to have played a role very early, helping matter collect into the first clumps that would later become galaxies. In this sense, it may have been present at the universe's youth, long before stars, long before planets, long before any eyes opened to watch the sky. It may have been part of the first scaffolding, the unseen framework upon which luminous matter could settle. That idea is especially moving when one considers the early universe as a kind of landscape still forming in mist, not yet the familiar cosmos of bright spiral galaxies and familiar constellations, but a vast, expanding field of potential. Tiny density differences, tiny variations in the cosmic afterglow, would later grow into immense structures. If dark matter was there, it was there as a patient organizer, a silent collaborator. It did not shine, but it may have helped everything that does shine find its place. This gives the mystery a gentle dignity. It is not merely a missing piece, it may be a preparatory one. There are analogies from old cities and old kingdoms that can help the mind settle around this. Some civilizations are remembered by the monuments that remain above ground. Others are understood through roads, trade routes, irrigation channels, and the shape of the buried earth beneath later settlements. One kingdom may vanish, but its influence persists in the layout of fields, in the names of rivers, in the fragments that survive in another culture's stories. The hidden foundation matters as much as the visible tower. So too with the cosmos. The most luminous parts of a galaxy are not always the most influential. The bright star does not explain the orbit alone. The glittering surface does not tell the whole truth of the current beneath it. In that sense, dark matter invites a different kind of respect. Not the immediate awe of fireworks, but the enduring awe of structure. If one were to imagine a map of the universe not as a painting, but as an old nautical chart, then the visible matter might be the coastlines, the islands, the ports. Dark matter would be the deep currents, the undersea ridges, the shapes that guide movement without ever breaking the surface. Mariners once understood that the sea had invisible geography. Astronomers now suspect the universe does too. It is also interesting to notice how often the history of science returns to the same emotional pattern. At first, the strange result seems like an error, then it refuses to go away, then more evidence accumulates, then theories multiply, then decades pass, then the mystery becomes part of the landscape of thought. This happened with the motions of planets. It happened with the behavior of atoms. It happened with the question of whether galaxies are isolated islands or part of a larger cosmic web. In each case, the unknown became less frightening once it became familiar. Dark matter has reached that stage. It is no longer a mere oddity. It is a durable part of our picture of the universe, even though the picture is incomplete. And there is a comfort in durable mystery. Not every unknown needs to be an emergency. Some unknowns are like distant weather beyond the horizon. They matter, but they do not require panic. They ask only for continued attention. There have been periods in the history of astronomy when hidden mass seemed to appear in very specific places and times. In the 20th century, galaxies offered one set of clues. Later, gravitational lensing offered another. Observations of the cosmic microwave background, the ancient afterglow of the Big Bang, provided a different sort of testimony. Each method has its own quiet authority. Each sees the universe from a slightly different angle, like listening to the same old song in another room. The cosmic microwave background is especially evocative because it lets us peer into a very early chapter. It is the relic light of a time when the universe was hot and dense, before stars took over the darkness, before galaxies became distinct, before the cosmic night acquired its present depth. Tiny variations in that ancient radiation contain clues about the content of the cosmos. In those faint ripples, the ratio of matter to dark matter can be studied with great care. It is a little like finding the pressure marks of a vanished hand in soft clay. There is something almost monastic in the patience required to extract meaning from such faint signals. It is not a glamorous pursuit. It is a conversation with noise and then with the silence beneath it. But from that silence comes a picture of startling richness. It becomes possible then to imagine the early universe not as a blank expanse, but as a nursery of hidden influences. Gravity gathering, heat fading, light escaping, matter cooling. The ordinary and the unseen moving together in a long choreography. Not a dance anyone could watch directly at the time, but a dance whose consequences are still visible today. Even the phrase dark matter carries a kind of poetic restraint. It does not claim to explain the substance in its essence. It merely names what our senses and instruments can presently say about it. It is dark because it does not interact with light in the usual way. It is matter because it seems to have mass and to gravitate. The name is practical, and that practicality itself has a calm beauty. It does not pretend to be more than it is. This is often how knowledge grows. First there is a label, then a shape, then a story, and only later perhaps a true identity. It may help to remember that the universe has already taught us how to live with invisible things. Wind can be felt but not seen. Time can be measured but not held. Memory can alter a life while leaving no visible trace. A childhood place can vanish and still remain intensely real in the mind. Entire cultures have disappeared, leaving only shards, walls, inscriptions, and legend. Yet disappearance never means complete absence. It often means transformation into another kind of evidence. Dark matter belongs to that family of realities, not the lost exactly, the inferred. Some of the most compelling astronomical mysteries involve the way light bends. When light from a distant object passes near a massive foreground object, it can be distorted, magnified, or split. This gravitational lensing has become one of the most useful ways of studying the hidden mass of the universe. It is a remarkable phenomenon, almost dreamlike in its implications. A mass so large that it curves space itself, and light obediently follows the curvature like a river bending around stone. The effect can make galaxies appear stretched into arcs, or cause multiple images of the same distant source. The sky becomes a kind of hall of mirrors, except the mirrors are not made of glass. They are made of gravity. Through these bends, astronomers can infer where the hidden mass lies, even if it does not reveal itself in the glow of stars. There is a quiet grandeur in that. To understand something by the path it bends, by the way it shepherds light, is a deeply elegant method. It feels almost like reading a history through the pressure marks on a page. And somewhere in the background of all this work is the patient confidence that the universe is coherent. That the hidden and the visible are not separate worlds, but one world with different modes of appearance. This confidence has been reinforced many times. Consider how the periodic table emerged from patterns not immediately obvious in the elements. Consider how the existence of Neptune was inferred from irregularities in Uranus's orbit. Consider how continental drift, once doubted, became plate tectonics, a story written in continents and ocean floors. In each case, something unseen was accepted because the visible world made no sense without it. Dark matter stands in that tradition. It is not a whim. It is a carefully weighed inference built from repeated observations across different scales. Still, it remains unsolved. And the unsolved quality is important because it keeps the subject alive. One can nearly feel the edges of possible answers, but not quite. Perhaps dark matter is one particle family. Perhaps there are several components. Perhaps some of the explanations involve physics beyond the standard model. Perhaps one of the current ideas will prove right. Perhaps the eventual answer will be stranger than the guesses we have now. That possibility deserves a slow thought. Physics has a way of being stranger in reality than in imagination, but also more disciplined. Nature often chooses the elegant surprise, not the theatrical one. The answer may be more subtle than anyone expects, and more beautiful for that very reason. There is a habit in human thought to want hidden things to be dramatic, secret kings, lost continents, cosmic monsters. But often the truth is quieter. A faint particle, a weak interaction, a field that extends through space, a principle that changes the outcome simply by existing. The universe does not always speak in thunder. Sometimes it speaks in low, enduring tones. This is perhaps why dark matter has captured the scientific imagination so deeply. It offers grandeur without spectacle, a vast influence without visible ornament. It is a reminder that scale alone can be breathtaking, even when the thing itself remains elusive. And if we allow our thoughts to drift a little further, we can imagine entire cosmic histories shaped by this elusive participant. After the first stars ignited, dark matter would already have been there, surrounding galaxies in halos, helping stabilize the structures that formed. Spiral galaxies with their graceful arms may owe some of their long-term coherence to that invisible gravitational presence. Clusters of galaxies, bound together across immense distances, suggest a mass distribution far greater than the light reveals. In a sense, the visible universe is nested inside a larger, darker one. That image can be held gently, a luminous city resting inside a much larger, unseen country. It is not difficult to see why artists and writers are drawn to such ideas. A hidden world beneath the world is one of the oldest and most persistent motifs in literature. Subterranean kingdoms, parallel realms, buried machines, forgotten empires beneath the sea. These stories do not simply entertain. They echo the intuition that surface reality is only a first layer. Beneath it, another order may be at work. Dark matter is not a fantasy realm, of course, but it does share that structural charm. It is an invisible domain that shapes the visible one. It is the understructure of a cosmos that at first glance seems built almost entirely from light. And because the topic concerns unseen things, it naturally reminds us of other unseen presences that have shaped human history. The principles of gravity were invisible long before they were described mathematically. Germs were invisible before microscopy confirmed what disease had hinted. Emotional bonds, cultural memories, inherited customs, all influence the shape of life while remaining intangible. There are many kinds of reality that do not announce themselves in bright and simple forms. So when the mind finds dark matter difficult, it may help to remember that difficulty is not evidence of impossibility. It is often just a sign that the matter in question belongs to a deeper layer of explanation. There are also quiet pleasures in the terminology itself. Matter suggests substance, weight, consequence. Dark suggests not evil as in old tales, but hiddenness. Combined, the phrase points to a kind of solemn invisibility, not a void, but a presence with no light signature. It is almost like the idea of an old library where the shelves remain closed, the catalogue incomplete, and yet the books are still there. One of the most wonderful features of astronomy is that it lets us meet such ideas on the largest stage imaginable. Dark matter is not a local oddity in a single laboratory. It appears to be woven through the cosmos. It may form halos around galaxies. It may help create the cosmic web. It may constitute a substantial portion of the total mass energy content of the universe. To think of that while lying awake at night is to feel both small and included. Small because the scale is overwhelming. Included because our little act of knowing is somehow able to touch it. That too is a kind of comfort. Perhaps the real lesson of dark matter is not only about the universe. Perhaps it is also about the dignity of patience. Some truths are not granted in a single instant. They arrive by accumulation, by repeated attention, by humble correction, by the willingness to say, "I do not know yet, but I see the shape of what must be there." That phrase could describe many useful forms of wisdom. It could describe a navigator following stars through overcast skies. It could describe an archaeologist brushing dust from a fragment and inferring a vessel. It could describe a listener hearing a familiar melody in fragments and recognizing it anyway. It could describe science itself at its best, not arrogance before the unknown, but trust that the unknown can be approached. And the approach matters. Dark matter has inspired immense effort because it sits at a crossroads of cosmology, particle physics, and fundamental theory. To explain it, one may need to understand the very smallest scales and the very largest. That is one of the grand recurrences of modern science. The tiniest and the vastest speak to one another. A particle could affect the fate of galaxies. A quantum field might leave a mark on the visible structure of the universe. There is poetry in that, though it is a sober kind of poetry. The ancient world loved correspondence too, though in different language. Macrocosm and microcosm, heavens and earth, the arrangement of the stars mirrored in the order of the soul. While modern science does not rely on those symbolic systems, it still finds itself discovering connections between scales. The universe, it seems, likes nested patterns. Perhaps that is why dark matter has such staying power in the imagination. It sits at exactly the point where the great and the small meet, invisible particles, if they exist, shaping cosmic architecture. The near-infinite built from the almost imperceptible, a reminder that reality may be assembled from things far gentler than our senses expect. In the end, the dark is not empty. It is full of unanswered questions, yes, but also full of structure, motion, and relation. The stars do not float alone. The galaxies are not isolated islands. The universe is threaded together by influences we are still learning to recognize. That knowledge does not disturb the night. It deepens it. So if the room has grown quieter now and the breath slower and the thoughts softer at the edges, let the cosmos remain as it is, vast, unfinished, and subtly held. Let the visible and invisible rest side by side. Let the old mystery of dark matter keep its place among the quiet wonders of the sky. Somewhere beyond the window, beyond the familiar outlines of trees and roofs and sleeping streets, the universe continues its long, patient accounting. Mass gathers, light travels, gravity curves what it must, and through it all the unseen remains faithful to its role, shaping the grand design without applause. It is a strange life, this dark matter, and perhaps that is why it endures in the mind. Not because it gives us a final answer, but because it teaches us how to sit gently with not knowing. And that, for the moment, is enough. The night can keep its secrets a little longer. The galaxies can keep their hidden weight. The universe can continue, as it always has, in calm relation to all the things we have not yet learned to name. And you can rest here, with the thought that even the unseen has a place, even the unknown belongs to the pattern, and even the dark is part of the cosmos's quiet way of shining. If you were to wander in imagination, away from the sleeping room and into the deeper country of the night sky, you might begin to feel how large a story dark matter really is. It is not a single idea sitting neatly on a shelf. It stretches across centuries of thought, across observatories and equations, across old charts and new instruments, across the human habit of noticing that something does not quite add up. That habit is older than any modern theory. Long before the word dark matter existed, people looked upward and asked careful questions of the heavens. In Mesopotamia, where astronomers kept records on clay tablets, the sky was not random. It was measured, repeated, watched with patient attention. The motions of the moon and planets were copied and compared over generations. In ancient Egypt, the stars helped mark seasons and ceremonial times, while the river rose and fell with a rhythm that seemed almost like a kind of terrestrial astronomy. In Greece, thinkers argued over whether the heavens were made of a perfect substance or whether the same principles governed both sky and soil. In China, court astronomers recorded comets, guest stars, and eclipses with a seriousness that preserved data for later minds who would never know their names. They did not know dark matter, of course, but they knew the dignity of observation, and perhaps that is the first quiet lesson in this strange story. The universe does not reveal itself all at once. It offers patterns, omissions, echoes, and refusals. A star is seen, a motion is traced, a discrepancy appears. Then, if one is patient, the discrepancy becomes the doorway. There are many old stories about hidden things affecting the visible world. In some myths, the underworld is not separate from life but intimately connected to it, a realm of influence beneath the bright surface. In others, the world rests on supports unseen, roots, pillars, deep foundations, vast creatures in the dark. The details vary, but the feeling is familiar. The scene is seldom the whole arrangement. Human beings have long suspected that what matters most may be concealed. Dark matter, in its own modern way, belongs to that family of intuitions. It is not a myth, not a spirit, not an ancient god hiding in the dark. It is a scientific response to a stubborn mismatch. And yet, because it is invisible and powerful and ubiquitous, it naturally awakens the same old sense of wonder that myths once carried. The 20th century brought the problem into sharper focus. Astronomers measured how galaxies rotate, how clusters of galaxies behave, how light bends around massive objects. The answer kept returning to the same quiet impossibility. There seemed to be more gravity than there was visible matter, more pull than the stars, gas, and dust could explain. Something unseen was there, steady and immense. The idea was not immediately embraced with certainty. Science rarely works that way. First comes suspicion, then models, then criticism, then more measurements, then a long period in which several explanations coexist uneasily. Sometimes the missing mass is ordinary matter too faint to see. Sometimes it is gas. Sometimes the method of analysis must be corrected. But the discrepancy persisted in many different forms across many scales, with a consistency that was difficult to ignore. That persistence is part of the calm beauty of the subject. A single odd result can be a mistake. A repeated odd result becomes a conversation with reality. As the decades passed, new instruments widened the conversation. Radio observations revealed neutral hydrogen extending far beyond the bright edges of galaxies. X-ray observations traced hot gas in clusters. Gravitational lensing, that elegant consequence of Einstein's theory, allowed astronomers to measure mass by the way it bends light, as if the universe were drawing its own faint topographic map in the sky. The lensing maps often showed that the visible matter was only a fraction of the total. It is a peculiar and lovely thing to think that light, which seems so effortless and free, can be gently steered by mass across millions or billions of years. A beam from a distant galaxy, having crossed unimaginable distances, may arrive to us slightly arced, duplicated, stretched, or magnified by some intervening cluster of matter. The cosmos is not simply seen, it is interpreted through the curves it imposes on light. In old maritime traditions, a sailor might infer hidden rocks from the break of waves or the color of the water. One did not need to see the obstruction directly to know it was there. The sea wrote signs upon itself. The universe does something similar, though on a grander scale and with more patience. It bends starlight, it nudges orbits. It arranges the large-scale web of galaxies into forms that seem to require more than what eyes can count. This hidden influence is sometimes described in terms of halos, vast spherical regions surrounding galaxies. The visible galaxy, bright and slender or spiral and luminous, appears to be only the glowing center of a much larger structure. The halo is dark, extended, and dominant in mass. If the visible galaxy is a lantern, the halo is the room it inhabits, though the room itself cannot be seen directly. Stars travel within this unseen environment, tracing its shape like dancers moving through a hall whose walls they cannot touch. And because the halo is so much larger than the luminous part, galaxies are not small islands of stars floating in emptiness. They are embedded in a deeper scaffolding. That scaffolding extends outward into filaments and nodes, into the vast cosmic web. Over immense scales, matter appears not to be distributed evenly, but woven into long strands, with voids between them, much as frost grows along a window or roots spread through soil. The visible galaxies are like small lights along those strands. The dark matter in many models forms the underlying skeleton. Without it, the web would be difficult to explain. There is a quiet grandeur in this picture. Not a dramatic one, but a patient grandeur, like the interior of a cathedral at dawn. The structure is there before one fully understands it. It shapes movement. It determines where things may gather. It allows complexity to appear. And yet, for all its importance, dark matter remains strangely aloof. It does not absorb light or emit it or reflect it in any way we know how to detect. It passes through ordinary matter almost without notice. If it is made of particles, they may interact only feebly with the familiar world. A grain of dark matter might pass through mountains, oceans, and sleeping cities without touching a single atom. This is not because it is magical, but because nature allows many forms of existence that are nearly impassive toward one another. The thought can feel eerie at first, then restful. Not everything requires our attention. Not everything must be allowed to be real. In the history of science, many invisible things were first inferred before they were seen. Neptune was calculated from irregularities in Uranus's orbit. Viruses were known before they were visible under the strongest microscopes. Radio waves were once invisible to human senses, yet they carried messages across distances. The practical mind learns to respect the unseen if it leaves consistent traces. A shadow on the floor implies a lamp above, or a hand, or a passing cloud. A gravitational discrepancy implies something in the arrangement of mass. Dark matter was not a single discovery, but a constellation of them. Galactic rotation curves, cluster dynamics, cosmic microwave background measurements, large-scale structure, and lensing all pointed in compatible directions. Different windows, same quiet pressure. The cosmic microwave background deserves a moment of gentle attention. It is one of the oldest lights in the universe, a faint afterglow from the early cosmos, now cooled to microwave temperatures by the expansion of space. It fills the sky in every direction, a nearly uniform whisper from a time when matter and radiation were still intimately coupled. Tiny fluctuations in this background tell us about the seeds from which galaxies would later grow. Those seeds, too, depend on the amount of dark matter. Without enough unseen mass, structure would form differently, perhaps too slowly, perhaps in forms unlike the universe we know. So in a way, every quiet map of the early universe is also a map of absence. It is a record of what visible matter could not do alone. The curiosity this inspires is gentle but persistent. What is dark matter made of? Is it one particle or several? Is it heavy, light, cold, warm, self-interacting, almost never interacting at all? Does it form tiny clumps or smooth halos or something more intricate still? The questions are numerous because the evidence is indirect. We do not yet have the privilege of handling the thing itself. That absence has encouraged many proposals. There are weakly interacting massive particles, often called WIMPs, a phrase that sounds almost unassuming for something so consequential. There are axions, hypothetical particles originally suggested for a different problem in physics, now among the most carefully watched candidates. There are sterile neutrinos, primordial black holes, and other ideas that come and go through the literature like constellations seen briefly through clouds. Each proposal is an attempt to give shape to the invisible. Science, in that sense, is often a kind of careful mythology, though one bound to measurement. It names the unknown in provisional terms, then tests whether the names hold. Some do not. Some must be revised. Some disappear. Yet the act of naming remains useful because it allows thought to continue. The ancient storytellers knew this too in their own way. A name did not settle a mystery so much as make it inhabitable. To call the dawn by one name and the sea by another was to acknowledge their distinctness while admitting their power. We now call things by particle names and field names and parameters, but the underlying gesture is similar. We make a place in language for what we cannot yet hold. Perhaps that is one reason dark matter is so compelling. It is a mystery with a disciplined shape, not a blank but a contour. There are measurements around it like shorelines around an unseen island. The island itself remains out of sight, but the waters around it are mapped. Some people imagine dark matter as a kind of cosmic fog, but that image can mislead. Fog scatters light and alters visibility. Dark matter, by contrast, does not behave like an obscuring cloud in the ordinary sense. It is better thought of as a hidden weight, a background presence. If the universe were an old room, dark matter would not be the dust in the lamp glow. It would be the joists in the floor, the support beams in the walls, the framework that makes the room stable. That framework is almost entirely beyond ordinary sensation, but the mind can still dwell on it peacefully. A house stands because of what is concealed, so does a galaxy. There are times when astronomers have found themselves in landscapes reminiscent of vanished cities. A cluster of galaxies seen through a telescope can resemble a ruined metropolis viewed from above, with bright centers, filaments, and dark spaces between. The comparison is only visual, of course, but it is evocative. Ancient ruins often teach us that what remains is only part of the original design. Walls fall, roofs vanish, courtyards fill with earth, and yet enough survives to suggest the whole. Dark matter is like the surviving foundation beneath a buried palace. It tells of an architecture no longer visible in full, and if one lingers on that image, it becomes easier to feel how science and archaeology sometimes mirror each other. Both examine fragments, both infer scale from partial evidence, both work in the patient interval between loss and understanding. The difference is that archaeology deals with the remains of human intention, while cosmology deals with the remains of the universe's own earliest structure. In each case, absence is informative. There is also a quiet humility in the way the dark matter problem resists easy closure. It reminds us that the universe does not owe us convenience. A theory may be elegant and still incomplete. A measurement may be precise and still not final. The hidden component of the cosmos may turn out to be a particle, or a field, or something stranger than current imagination can comfortably hold. Whatever the answer, it will have to account for many facts at once. Reality is not impressed by simplicity alone. Still, one can rest in the search itself. There is no need to solve the cosmos before sleep. One may simply let the mind move through the long chain of discovery, from old Babylonian observations to modern detectors buried deep underground, from the quiet scribbling of a chart to the delicate architecture of a cryogenic experiment. Some of these detectors are placed far beneath mountains or in deep mines, shielded from cosmic rays and the constant chatter of ordinary particles. They listen for the faintest possible interactions. It is a strikingly peaceful form of listening. Not all instruments are noisy. Some wait in darkness for years, hoping for a single rare event. That patience feels almost monastic. The underground laboratory becomes a kind of modern cave, not unlike the caves in old stories where seekers went to encounter hidden truths, except here the hidden truth is not a god or prophecy, but a particle perhaps, or a sign of one. The analogy is not perfect, but it is gentle. There is a strange beauty in experiments that do not promise certainty. They simply continue. They cool, they record, they exclude, they refine. They teach what is not there, which is often nearly as important as what is. If a candidate particle fails to appear in one search, the allowed space narrows. If another measurement agrees with a different method, confidence slowly accumulates. This is how the invisible becomes less mysterious, not in a sudden unveiling, but in the gradual closing of possibilities. Meanwhile, astronomy keeps offering its broader perspectives. Surveys map millions of galaxies. Simulations attempt to recreate cosmic growth from initial conditions to the large web of today. On screens and in printed figures, clusters appear, filaments extend, voids open. These voids are not true emptiness, perhaps, but lower density regions, quieter stretches of the cosmic fabric. Even there, in the apparent emptiness, the universe is still active. Like crosses, expansion continues. Structure edges along its long road. Some of the largest voids are astonishing in scale. They are not holes in the sense of absence from being, but regions where matter is sparse, like the wider silent spaces in music. A composition needs rests. The cosmos, too, seems to include intervals. The galaxies gather where gravity has won more of the argument and drift apart where it has won less. Dark matter influences both gathering and leaving. The language of music is apt here because dark matter is known mostly through harmony rather than single notes. Each observational field contributes a phrase. Rotation curves repeat a motif. Lensing repeats it differently. The cosmic microwave background answers with a low, ancient hum. Simulations provide counterpoint. The result is not complete melody, but a slowly emerging score. It is worth remembering that not every mystery remains forever obscure. There was once a time when the composition of stars was hidden. Their spectra revealed elements unknown on Earth, and later the same elements were recognized across the cosmos. There was once a time when galaxies themselves were debated as island universes, and the scale of existence was not yet settled. There was a time when no one knew that the universe expands. Each of these mysteries seemed at one point almost unyielding. The same may one day be true of dark matter, or it may not. That uncertainty is not failure. It is simply the present shape of knowledge. Somewhere in the long future, perhaps a student will read about this era the way we now read about epicycles, ether, or alchemical symbols. They will see what was tried, what was abandoned, what was insight and what was error. That future judgment, whatever it is, will not diminish the care of those who work now. Each generation stands at the edge of what can be known and places its careful instruments into the dark. There is another kind of patience in all this, one that belongs to the universe itself. Stars take millions or billions of years to form and change. Galaxies merge over vast spans that make human history seem like a brief weather pattern. The growth of large-scale structure is slow, nearly ceremonial. Dark matter participates in these processes over timescales that dwarf the rise and fall of empires. Empires, too, once believed themselves permanent. Their capitals were built of stone and pride. Their roads extended through forests and deserts. The earth keeps quiet records. Cities become ruins. Harbor walls sink beneath silt. Temples are reclaimed by roots. What remains is often a fragment, a column, a coin, a half-buried inscription. From these fragments we infer the living whole. In that sense, the universe is more archaeologically legible than a destroyed city because gravity preserves its evidence in the motions of things. A galaxy still spins, a lens still bends, a cluster still binds. The ruin is not dead, only old. Its hidden framework continues to operate. One might even say that dark matter is an ancient resident of creation. Whatever it is, it appears to have been present early, helping shape the first assemblies of matter. It may have been there before stars blazed, before planets cooled, before the chemistry of life became possible. It is older than oceans, older than mountains, older than every story ever spoken beside a fire. And yet it remains close to us, passing through the room, through the body, through the night, almost unperturbed. If it is a particle population, then countless such particles may be coursing through every square centimeter of space at this moment, indifferent to walls, instruments, and perhaps even to the Earth itself. That indifference is not hostility. It is simply a different way of belonging to the universe. The human mind often prefers things it can hold, but it can learn to cherish what it cannot. We do this already with time, with memory, with grief, with the future. We know them chiefly by what they do. Dark matter is one more lesson in the legitimacy of inference. Sometimes, when one studies a scientific mystery for long enough, it begins to feel like an inhabited landscape. The equations are not abstract symbols but paths. The datasets are not merely numbers but trails through a marsh or over a ridge. The competing theories become neighboring villages, each with its customs, each promising a way across. And in the middle of the landscape stands the unseen hill, the one that alters all routes while remaining itself just beyond direct sight. A traveler at dusk might not need to climb that hill in order to know it is there. The rivers curve around it. The shadows lengthen differently because of it. The air has another feel on its leeward side. Such is much of cosmology. We are surrounded by effects whose source we infer through the shape of the world they make possible. There is also something tender in the idea that the universe is not fully transparent. Complete transparency can be harsh. Mystery gives the mind room to breathe. It allows curiosity to sleep beside uncertainty rather than fight it. The unknown is not always a threat. Often it is simply the next room unlit, waiting for a lantern. And science, when it is at its best, is a way of making that lantern without pretending to fill the whole house at once. It advances by careful illumination. A corner becomes visible, then a corridor, then a window, then another corridor beyond the first. The dark matter problem has already illuminated many such corridors, even if the main chamber remains dim. In this light, the search itself has changed the way we see the visible universe. We no longer picture galaxies as isolated ornaments scattered through nothingness. We see them as parts of a larger arrangement, shaped by hidden mass and cosmic history. We understand that the bright matter, the atoms, the stars, the gas, the planets, the dust, may be only a small portion of what exists. The rest is an invisible majority, modestly indifferent and profoundly important. This idea can feel almost philosophical, and perhaps it is. Human beings have often been tempted to equate visibility with significance. The brightest object, the loudest voice, the most apparent feature, but dark matter quietly suggests another order. Some things matter most precisely because they are not easy to see. Some structures hold because they do not call attention to themselves. A bridge carries weight by being strong, not by being seen. A root nourishes a tree underground. A memory shapes a life from within. A continent's geology determines the course of rivers long before any river is named. The universe, in its own scale, seems to favor this kind of hidden support. There are moments in history when civilizations reach toward hidden order through astronomy. The builders of megaliths aligned stones to solstices and lunar cycles. The priests of old temples tracked the sky to synchronize ritual and season. The inhabitants of ruined ceremonial centers in the Americas and elsewhere arranged terraces and sightlines with astonishing care. They did not know dark matter, but they knew that the heavens carried structure, and that structure could be read. Their monuments, many now worn by weather and time, are records of attention. Modern observatories continue that attention with sharper tools. Radio arrays, optical surveys, space telescopes, gravitational wave detectors, neutrino observatories, and deep underground experiments each contribute a different kind of listening. It is a world-spanning effort, yet still intimate in spirit. Human beings sitting at consoles, comparing curves, correcting instruments, and waiting. The waiting is part of the work. Sometimes, in the quiet hours before dawn, an astronomer may look at a simulation or a chart and feel a small kinship with an ancient scribe bent over a tablet. Both are trying to preserve a pattern before it slips away. Both know that records outlast the moment. Both work under the same patient sky. And the sky itself, though now understood in ways earlier ages could hardly imagine, remains a place of awe. The Milky Way crosses it like a pale river, Constellations assemble into familiar shapes. Beyond them lie galaxies, clusters, and the invisible lattice of dark matter. The distance between the visible and invisible is not a barrier but a layered depth. One can think of the night as a fabric with many threads, some luminous, some hidden. There is no need to force the mystery open. It is enough for now to let it be known as a mystery with evidence, a mystery with contour, a mystery that has shaped our understanding of cosmology and that continues to invite new forms of care. Because care is what underlies all honest discovery, care in calibration, care in interpretation, care in the refusal to overstate, care in the willingness to let a model be corrected by the universe. It is a form of respect, really, and perhaps that respect is what makes science not merely clever but noble. The noble thing about dark matter is not that it is dramatic. It is not. The noble thing is that it teaches us to notice dependence where we assumed independence. It shows that visible order may rely on hidden order. It asks us to honor what supports the whole. This applies beyond cosmology, gently and without insistence. Many lives are held together by unseen work. Many communities rest on unnoticed effort. Many histories are preserved by anonymous hands. The way a city functions at night depends on people most of us never meet. The way knowledge survives depends on teachers, archivists, technicians, translators, and keepers of detail. The unseen is not lesser, often it is foundational. Dark matter then becomes more than an astronomical problem. It becomes a mirror for the quiet logic of the world. What is essential may not be visible. What is large may be silent. What is hidden may still guide everything around it. And because this is a bedtime story, it is enough to let that thought settle like dust over a shelf. No need to pursue it further tonight. No need to chase the particle through all the laboratories and theories where it may be waiting. No need to name the final answer before sleep arrives. Instead, imagine the universe at rest in its own way. Not static, never static, but calm in motion. Galaxies turning slowly, clusters holding together, light traveling along curved routes. Far from our planet, the dark scaffolding remains at work. Near our room, the shadows lengthen softly. The air stills. The world becomes simpler, not because the cosmos has become less complex, but because we have allowed ourselves to listen more gently. In ancient times, people sometimes imagined that the stars were set in layers, each heaven more distant and subtle than the one below. Those cosmologies were incomplete, but they carried an intuition worth keeping. The universe may have depths we cannot easily traverse, and each depth can have its own law of motion and stillness. Dark matter belongs to one such depth. Not a heaven, not a realm of spirits, but a domain of physical reality that remains faint to our senses and profound in its consequences. It is not necessary to solve it this evening. It is enough to know that the question exists, that the question is alive, and that the answer, when it comes, will likely broaden our sense of what the cosmos has been all along. Until then, the unseen can remain unseen. The visible can continue to shine. And you, if you are ready, may let the mind loosen its grip on the search and rest instead in the simple fact that the universe is larger than certainty, older than memory, and gentler than fear. The dark matter of the sky is not a void. It is a presence we have not yet learned to meet directly. It shapes the great architecture of galaxies, like the deep foundation beneath an ancient temple or the hidden root system beneath a forest. It may be particle, field, or something still unnamed. Whatever it proves to be, it has already taught us something precious, that the world is held together by influences that do not ask to be seen. And so the night can continue its quiet work, the stars can keep their distant vigil, the unseen can remain patient, the questions can wait, the room can grow softer and smaller around your breathing, while beyond it all the cosmos goes on, vast and exact, holding its hidden structures in calm relation. Sleep then, if sleep is near. Let the mystery be restful. Let the invisible keep watch. And if the thought lingers a little longer, that is all right. Some ideas do not need to be solved before they become comforting. They only need to be held lightly like a small lamp in the hand while walking through a quiet corridor. Dark matter is one of those ideas. It does not behave like a story with a clear beginning and an ending. It is more like an old map with missing coastline, a chart made by sailors who knew the shape of an island by the way the waves bent around it. We know it by its influence. That is often how the oldest truths arrive. Long before anyone saw the full shape of a place, they knew where to expect the river by the green valley it left behind. Long before anyone understood the seasons in detail, they knew the time to plant by the return of certain stars. Long before a child understands the hidden reasons for a household's rhythm, the child knows the comfort of the rhythm itself. Cause can be invisible while effect remains beautifully plain. In the 20th century, astronomers began to find that the universe was behaving as though much of its mass were missing from view. The numbers did not quite settle. The galaxies spun too quickly at their edges. Clusters held together more strongly than the visible matter alone could explain. It was as if the cosmos had been built with a secret beam running through its center, strong and silent, supporting the whole structure. That kind of discovery can feel almost like an old myth with the magic removed and the wonder left intact. In older stories, there are hidden pillars beneath the world, great roots beneath the sea, cosmic turtles carrying continents, or invisible chains tying the moon to the underworld. These are not scientific explanations, of course, but they are expressions of the same human intuition, that what is seen may rest upon what is not seen, and that hidden support can be as real in its own way as stone. There is something very ancient in this suspicion of surfaces. The people of Mesopotamia looked up at the stars and saw messages written across a vast and unreadable ceiling. The Egyptians mapped the sky with care, knowing that the motions overhead echoed the deeper order of time and kingship. The Greeks imagined spheres nested within spheres. Chinese astronomers recorded comets, eclipses, and shifting lights with patient precision. Across many civilizations, the heavens were never simple. They were layered, inhabited, interpretive. Dark matter, in a quiet modern way, carries forward that same sense of layered reality. It is not a myth, but it fits the emotional shape of myth, the discovery that the world contains more than the eye first grants. A bedtime mind can rest with that slowly. There is no urgency in it, no need to chase every branch of the problem. It may be enough to sit for a while with one small fact. If dark matter exists as we think it does, then the visible universe is only a fraction of the full story. Stars, gas, dust, planets, mountains, oceans, bones, cities, and the thoughts within them are all luminous and familiar, and yet they are not the whole inventory of reality. Something quieter lies alongside them, less eager to announce itself. That can feel unsettling if one insists on certainty. But in the stillness of night, it can feel almost tender. The universe is not obliged to make itself obvious. A forest is not less rich because most of its life is underground. A winter lake is not less deep because the surface looks smooth. A family history is not less true because some of its chapters are missing. Absence of visibility is not absence of being. Astronomers have spent decades tracing the outline of this hidden matter through many forms of observation. They watch how galaxies rotate. They study how light bends around massive objects in the process called gravitational lensing, where a cluster of matter acts almost like a natural glass, curving the path of distant starlight. They examine the cosmic microwave background, the faint afterglow of the early universe, which preserves a kind of ancient record of how matter gathered and separated. They compare simulations with observations, refining models patiently, like conservators working to restore a mural whose colors have dimmed with age. And still the full answer waits. That is common in science and perhaps in life too. The question remains open not because it is empty, but because it is full. There is space inside it. There is room for humility and room for wonder. One can imagine the scientists working in observatories on quiet mountains, or in underground laboratories shielded from ordinary noise, or at desks with screens glowing softly in the dark hours before dawn. Their work is not unlike that of ancient scribes copying a text by lamplight, or monastery keepers preserving a manuscript through centuries, or navigators taking notes in the cold on a deck that swayed under stars. The setting changes, but the attention remains. A patient human being looks into a mystery and does not rush to end it. Dark matter has inspired many kinds of theories. Some imagine particles that barely interact with ordinary matter except through gravity. Some consider axions, WIMPs, sterile neutrinos, or other candidates that sound almost like characters from a hidden court. Each idea has its own elegance and difficulty. Each is a possible doorway. None has yet opened fully enough to let us walk through. The question remains beautifully unfinished. That unfinished quality is part of the bedtime mood too. Sleep often comes not when every loose thread has been tied, but when the mind is permitted to leave some threads hanging. A hallway with doors still closed can feel peaceful if we know there is no one behind us. A shelf of unread books can be comforting when we are not required to read them all tonight. The universe, with its many unanswered questions, may be like that shelf in a much larger house. Some volumes are simply not for this evening. There are places on Earth that make a similar impression. Ancient ruins in desert light can feel almost like they belong to a hidden layer of time. At Petra, where stone facades glow rose-colored at dawn, one senses the vanished Nabatean world not by seeing its full life, but by noticing the surviving edges of it. At Machu Picchu, terraces and temples cling to the mountain, and the mist seems to keep their secrets gently rather than erase them. At Angkor, tree roots and stone blocks have negotiated their long silence together. At Great Zimbabwe, walls remain with an authority that does not require explanation. In each case, what endures is not a complete narrative but a presence, a trace, a shape around an absence. Dark matter leaves a similar trace in the sky. Not of a lost city, but of an unseen architecture. We infer its mass through the way galaxies behave, just as we infer a buried chamber by the way the floor above it sounds hollow under careful footsteps. The analogy is not exact, but it is restful to think with such analogies. Human understanding often advances by resemblance before precision. We begin with a familiar form and only later discover its limits. There is, too, a long history of people seeking hidden substances in the heavens. Alchemists once imagined quintessence, a fifth element more subtle than earth, water, air, and fire. Philosophers proposed ether, an invisible medium through which light might travel. Some ideas endured for centuries before yielding to better measurements. Others disappeared, but not before they shaped the imagination of discovery itself. Even incorrect models can prepare the mind for more accurate ones. They can teach patience. They can train attention to ask what supports the visible, what carries the motion. What remains after the labels are changed? The answer for dark matter is still provisional, yet the search itself has become a kind of slow astronomy of humility. We have learned that the universe does not owe us simple categories. We have learned that nature sometimes withholds its mechanisms while still revealing its results. We have learned that mathematics can point toward what the senses cannot easily grasp, and that this pointing is a form of knowing, even before the object is touched. The scale of the cosmos makes this even more delicate. A galaxy is not a small thing. It may hold hundreds of billions of stars. The Milky Way is only one among many, and it drifts within a cosmic web of filaments and voids, a structure so large that our ordinary intuition becomes quiet in its presence. Some regions are dense with galaxies, some are emptier than loneliness. Across this web, dark matter may form the underlying lattice, as if the visible universe were a garden laid over a more fundamental trellis. And yet, for all its immensity, a single night can still feel personal. The same universe that contains galaxy clusters also contains a windowsill, a glass of water, a curtain moving a little in the dark. The same gravity that shapes the motion of galaxies also pulls a blanket gently toward the floor. The same laws are at work in the large and the small, but they arrive at different scales with different accents. That is another quiet wonder. The same reality can be majestic and domestic at once. Some people like to imagine what the universe would look like if dark matter glowed. Perhaps it would appear as a faint, bluish haze surrounding galaxies, or as a web of translucent threads across intergalactic space. Perhaps it would gather in great halos around clusters, like a moonlit fog. These are only imaginative pictures, and likely nothing close to the actual thing, but the mind enjoys giving shape to what resists it. Children do this naturally. They imagine hidden rooms in the walls, secret ladders behind the bookshelf, tiny kingdoms beneath the floorboards. Scientists, in their own careful way, do something not entirely different when they model the invisible. It may be useful before sleep to think of dark matter not as a failure of knowledge, but as an invitation to wider patience. A failed lantern is frustrating. A covered lantern is intriguing. The universe seems less like a broken machine and more like a carefully sealed manuscript, with portions legible and portions left for another reader. We are allowed to know enough to be astonished. We are not required to know everything. There is a softness in that thought. Some answers arrive late not because they are unkind, but because they need time to become visible. Seeds spend their first life underground. Fossils wait inside stone until some patient hand finds them. Forgotten languages can sleep for millennia before a key is discovered. The Rosetta Stone did not create the ancient script it helped reveal. It simply provided a bridge. Dark matter may one day be understood with a comparable bridge, something small and exact that suddenly connects many disconnected things. Meanwhile, the cosmos continues its unhurried behavior. Light from remote galaxies reaches us after journeys lasting millions or billions of years. Some of that light passed through regions where mass bent its route, leaving tiny distortions for us to decode. Some of the light came from eras when the universe was young and its structures were still gathering themselves. To study such signals is to practice an almost ceremonial kind of listening. Not all listening is done with ears. There is a deep pleasure in such attention. It is quiet, but it is not empty. It is the pleasure of being in the presence of something larger than one's own concern. It is the feeling of sitting beside an old river and realizing that its motion has no need to hurry. It is the feeling of entering a library where the books are arranged by centuries, not by urgency. It is the feeling of looking at the night sky and understanding gently that the darkness between the stars is not merely empty blackness, but a medium of distance, structure, and possibility. Some ancient cultures placed powerful meaning in darkness itself. Not fear exactly, though fear was present at times, but reverence for what cannot be held in daylight. In myth, darkness often serves as the place of origin, the womb of creation, the hidden chamber before emergence. In some traditions, the world begins in a deep, undefined quiet. In others, the first gods emerge from a primal sea or shadow. The human mind seems to know in a symbolic way that hiddenness can be generative. Not everything begins in brightness. Dark matter belongs to science, not myth, and yet its role in the universe feels a little like that. It is not the story's protagonist in the usual sense. It does not shine center stage. But perhaps it is part of the stage itself, the unseen structure that allows the performance of visible things. Without it, galaxies might not form as they do. Without it, the universe's arrangement would be altered beyond recognition. In that sense, dark matter participates in creation not by appearing, but by holding. The idea can settle gently into the mind. Holding is also a cosmic action. A cradle holds, a shoreline holds the sea, a bridge holds travelers, a mountain holds snow. A memory holds a lost voice. A careful friend holds a silence without breaking it. The dark matter of the universe may hold on scales that are difficult to imagine, but the principle is familiar. Strength does not always announce itself. Support is often quiet. In the history of astronomy, many breakthroughs have come from noticing an arrangement that did not quite fit the expected pattern. Uranus's orbit led to the prediction of Neptune. The wobble of a star can suggest an unseen companion. the slight redirection of light can betray mass that is not directly visible. In this way, the universe leaves clues like an old house with footprints in the dust. The clues are subtle, but they are enough for those willing to look closely. That close looking is in itself a kind of gentleness. It refuses to dominate. It does not insist that reality becomes simpler to accommodate our comfort. It says instead, let us be accurate and let us be humble. This is a fine attitude for the edge of sleep. One need not conquer the unknown before bedtime. One may simply acknowledge it and let it stand. If there were a museum of invisible things, dark matter would belong there among other elusive presences. The scent of rain before it falls, the pressure change before a storm, the memory of a language no longer spoken, the outline of a city under sand, the weight of a letter never sent, the pause before a song begins. None of these are empty. They are charged with anticipation or residue. They show that what is absent to immediate view can still be full of meaning. Of course, dark matter is not an emotion, not a memory, not a metaphor only. It is part of the physical universe, and its reality is measured in equations, observations, and cosmological models. Still, human beings understand better when they can place new knowledge beside old forms of thought. The universe is not less scientific because it can also be felt as symbolic. Sometimes symbolism is simply the older bridge between one kind of understanding and another. It is pleasant to think that the night sky has always invited such bridges. Ancient shepherds, priests, sailors, and philosophers looked upward and saw regularity, mystery, warning, and comfort. The same stars that guided caravans across deserts also inspired calendars and myths of origin. Later, telescopes extended our sight and then extended it again, and still again, until we could trace structures vast enough to make the imagination grow quiet. The sky became not smaller with knowledge, but deeper. Dark matter deepens it further. It gives the heavens a hidden texture, like velvet seen in dim light. It suggests that the cosmos has an underlayer, a support system, an almost architectural logic that is not obvious unless one studies the way the visible parts behave together. And because so much of the universe appears to rest on this hidden layer, the topic takes on an almost ethical atmosphere. It reminds us not to mistake the loud for the important or the obvious for the complete. There are people in every age whose work resembles dark matter in this sense. They are the archivists who preserve records no one else has time to read, the repairers who mend pipes behind walls, the analysts who check measurements twice, the translators who carry meaning across languages, the quiet gardeners who keep a place alive through seasons of neglect. History often celebrates the visible figure at the podium, but the deeper continuity belongs to those who keep the structure intact. This is not sentimental, it is simply how systems endure. When one thinks of the cosmic version of that quiet labor, the mind may rest more easily with the idea that not all importance is obvious, not all influence is bright. Some things are effective precisely because they remain in the background. Dark matter may be background in this sense, though background is too small a word for it. It is more like the canvas stretched behind a mural, or the submerged base of a glacier, or the unseen support beams in a cathedral ceiling. The visible beauty depends on the hidden engineering. And what a cathedral the universe is, if one chooses to picture it that way. Not a building made by hands, but a structure of astonishing scale, with light as its stained glass and time as its nave. In that immense place, galaxies are like lamps suspended at varying distances, and between them lies the dark, spacious air of the cosmos, threaded with unseen matter and motion. The metaphor is imperfect, but it offers a kind of peace. Large things can be contemplated through familiar forms without reducing their majesty. There is perhaps a reason that people return so often to architecture when describing the universe. We feel at ease when we sense that things are held in relation. A roof, a wall, an arch, a column, these are old companions of the mind. Dark matter suggests that the universe has a comparable grammar of support. We may not know the full syntax yet, but the sentence of reality continues to stand. In the far future, perhaps, a child in a classroom will learn the final form of this answer with the same calm certainty with which students now learn the names of planets or the structure of a cell. Perhaps dark matter will turn out to be one elegant mechanism among others, once hidden only because our tools were not fine enough. Or perhaps it will open into a more surprising landscape, revealing new fields, new interactions, new aspects of gravity itself. Either way, the lesson will remain dignified. The universe exceeded our early models, and it likely still does. That is not discouraging. It is generous. Generosity is not a word often attached to cosmology, but perhaps it should be. The universe has given us enough order to study and enough mystery to sustain wonder. It has provided laws that can be written, yet also depths that can be revisited for generations. It has not exhausted itself to us all at once. In that sense, it has the patience of an old storyteller who knows when to leave a pause before the next line. The night outside may now be very quiet. The trees are perhaps still. The roads are less busy. Somewhere a distant train might move through the dark with its own subdued confidence. Somewhere a lighthouse turns. Somewhere a city sleeps with thousands of windows dark and a few glowing softly, each one holding a private world. All of them exist under the same invisible conditions. Gravity, time, air, the spread of matter, the broader shelter of the cosmos. Much of what protects us is unseen because it has become so ordinary. The ordinary is often a disguise for the profound. Water is ordinary until drought. Air is ordinary until the wind changes. Daylight is ordinary until one remembers a long winter afternoon or a room with no windows. In a similar way, visible matter is ordinary because it is what we first learned to name. Dark matter remains a little astonishing because it resists easy naming, yet both belong to the same reality and both participate in the same vast hush. There is no need to draw the mystery toward the bed and pin it there. It may float above the room, patient as a high cloud, while you drift farther from the need to understand it. Some parts of knowledge become clearer when we stop gripping them. The mind, like a hand, can relax. The shoulders can soften. The breath can lengthen. The universe can remain complicated without demanding anything from you tonight. A final thought may be enough. If there is hidden structure everywhere, then perhaps you are also more supported than you can see. Not by dark matter in any literal personal sense, but by many quiet realities, by memory, by habit, by kindness already given, by the routine of the day, by the resilience that has carried you through other evenings, by the fact that the world, despite its vastness, keeps offering a place to rest within it. The ancient navigators looked for fixed stars because they needed a steady point in the turning sky. We too may keep a few steady points, the small lamp, the familiar room. The breath going in and out. The thought that the universe is deep but not hostile, mysterious but not chaotic, hidden in places but still lawful and patient. Dark matter belongs to that patient lawfulness. It is one of the great quiet arrangements of existence, and so the story can drift onward without strain. The galaxies can remain in their spacious procession. The unseen mass can continue to guide their turning. The old question can wait, wrapped gently in theory and observation, while the body rests and the mind loosens its hold. The night does not require final answers, it only asks for softness. In that softness, even the unknown can become kind. And if sleep is near now, let it come without ceremony. Let the cosmos continue its hidden work. Let the ancient mystery remain serene. Let the visible stars shine while the unseen structures hold them in place. Let the room darken a little more. Let the thoughts thin and drift. Let the quiet stretch around you like a very old and very patient sky.